additional problems on Maclaurin series. Hello future engineers and my dear students, welcome back to Mudassir Academy. In the previous video, we started with the Taylor's and Maclaurin series, and as we are focused only on the VTU examination point of view, we solved a couple of problems on Maclaurin series. One, as I mentioned, that is wise group log secant x was very important as it has been asked many times in examination. So, if you haven't watched the video, then please find a link in the description below. So, today's video will be continuation of the previous videos. As I told you, I will be solving some more examination problems today. One of them is expand root of 1 plus sin 2x using Maclaurin series. See, if you see this question and you refer the previous question papers, you will find this question asked multiple times in the final examination. So, please see, watch how I am doing, watch it multiple times and practice with me so that you don't lose marks in the examination. So, let's solve this problem, and before solving, if you haven't subscribed, then please consider subscribing and sharing this video with your friends as much as possible. This is going to give me more courage to make more videos for you like this even in my present health conditions. So, let's without wasting time start solving the maths. See, the question here is expand root of 1 plus sin 2x using Maclaurin series up to term containing x raised to 5. The other way this question may be asked is, or using Maclaurin series, prove that root of 1 plus sin 2x is equal to 1 plus x minus x squared by 2 plus x raised to 4 by 24 minus x raised to 5 by 120. So, as I mentioned, Maclaurin series is nothing but expansion about 0. Okay, so let me the first always to start with the question, write the Maclaurin series if you want to get marks. So, the series here is y of x is equal to y of 0 plus, since I am doing it Maclaurin series, it will be x into y1 of 0 plus x square by 2 factorial into y2 of 0 plus x cube by 3 factorial into y3 of 0 plus x raised to 4 by 4 factorial into y4 of 0, and you see that they are asking you to expand up to term containing x to 5, here is x to 5. So, we write one more term here plus x raised to 5 by 5 factorial y5 of 0. That means here you need to find this one is y of 0, y1 0, y2, y3, y4, y5, put it here, that is the series expansion. That is it, as simple as that. So, now this question is very simple. See, you see here root of 1 plus sin 2x looks a little confusing. So, let us see how to solve. So, first we have y is equal to root of 1 plus sin 2x. So, recall this question was a 1 marker in your entrance exam or your 12th exams or when you are learning trigonometry. See, how you used to solve it? It was very simple. 1, we know the trigonometric identities, we can write sin square x plus cos square x is equal to 1. And there is one more identity, that is sin 2x can be written as 2 sin x into cos x. These are very two important trigonometric identities. Now, what I will do, I will put them here. See what happens. So, this will be now root of, what is one? I write one as sin square x plus cos square x, and sin 2x I write as plus 2 sin x into cos x. Okay. Now, if you see this, it will become a beautiful relation, sin square plus cos square plus 2 sin x cos square. A square plus b square plus 2ab. Am I right? So, this looks like what? A square plus b square plus 2a into b. That's all. So, what is a square plus b square plus 2ab? Identity, simple identity. It's a plus b the whole square. A plus b the whole square is equal to a square plus b square plus 2ab. Am I right? So, this will be now. So, y will be equal to root of sin x plus cos x the whole square. Now, as you know, root square, root means raised to 1 by 2, square of root means it cancels off. Alright. So, sin x plus cos x 2 raised to 1 by 2, 2 cancels. So, we have it here as simply implies the easiest the question becomes is y is equal to sin x plus cos x. See how easy it is. It differentiates 1 time, 2 time, 3 time, 5 time, 10 time, 100 times. It's very easy. Correct. So, from this complex function root of 1 plus sin 2x, I used my trigonometrical identities and brought the question to a very simple form. Now, from this simple form, let us find the value of y0, y10, y2, so on, where y1, y1, y2, y3, y4 are the successive differentiations. That's it. And you know, differentiation sin x is cos x, differentiation of cos x is minus sin x. That's it. Okay. So, we have first y is this much. So, what is y of 0? Y of 0 will be sin 0. I write here first sin 0 plus cos 0. As you know, sin 0 is 0, cos 0 is 1. So, it is what? 1. So, we have y of 0 is 1. Then y1 is equal to differential sin x is cos x and differential cos x is what? Minus sin x. Okay. So, again we have y1 of 0 is equal to, it will be again cos 0 is 1 minus sin 0 is 0, that is 1. Next, we have y2 is equal to, see how easy it goes. Again, differential cos x is minus sin x and minus sin x is cos x. So, we have here y2 of 0 is equal to minus 0 minus cos 0 is 1, that is equal to again 1, that is sorry minus 1. Okay, 1 minus 1. Then again the next differential y3 is equal to, what is that? Sin x is cos x, so minus cos x minus differentiation of cos x is minus sin x, so minus into minus become plus, so plus sin x. So, we have y3 of 0 is equal to, see minus cos 0 is 1 plus 0, that is again minus. Very good. Now, the next one is y4. So, what is y4? y4 is equal to, again differential cos x is minus 1. So, minus is sin x, then minus into minus becomes plus, plus sin x is cos x. Therefore, y4 of 0 is equal to 0 plus 1, that is 1. And lastly, since they are asked to find only up to the x to 5 terms, so y5 will be the last differentiation here. So, we have y5 is equal to differential sin x is cos x minus cos x is differential cos x is minus sin x. So, clearly in a very simple way, y5 0 is cos 0 is 1 minus 0, that will be 1. That's it. Therefore, let us put in the series. So, we are solving for, so we can write that root of 1 plus sin 2x equals to, so put in the series now. So, what is this? Tell me. So, we have y of 0 1 plus x into, what is y1 0? Just put a value, say y0 1, x into y1 0 into 1 plus x square by 2 factorial. What is y2 0? Minus 1 plus x cube by 3 factorial. What is this? y3 0, again minus 1 plus x raised to 4 by 4 factorial. Am I right? By 4 factorial. What is y4 0? Again it's into 1. And lastly, plus x raised to 5 by 5 factorial into again this is 1. That's all. Am I right? Now, as you know, this is the answer. Sometime if they ask this, you can end here the answer, but they are asking the numbers here. So, as you know, factorial very easy. 2 factorial is 2, 3 factorial is 3 into 2 6, 4 factorial is 4 into 3 to 2, that is 24, and 5 factorial is 120. That implies the answer is implies root of 1 plus sin 2x is equal to, so the answer will be now 1 plus ax minus x square by what is 2 factorial? 2 itself. 3 factorial is 6 minus x cube by 6 again. 4 factorial is 24 plus x is to 4 by 24, and finally x is to 5 into 1 is 1, and 5 factorial is what? 120. So plus x raised to 5 by 20 plus 1. So this is the answer. That's it. So the expansion of root of 1 plus sin 2x can be beautifully written in the series form using Maclaurin series as 1 plus x minus x square by 2 minus x cube by 6 plus x is to 4 by 24 plus x is to 5 by 120. That's it. Yes, beautiful. Understood? So practice it correctly 2-3 times, then 100% you will get the knack of how to solve it. Okay, and you will get full marks in the examination. Fine. So let's solve the next question. Expand e raised to sin x using Maclaurin series up to the term containing x raised to 4. Okay, so first, as I told you, you need to write a series, that is up to x raised to 4. They already given it as Maclaurin. So let's write a series here. So we have the series as y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial into y2 of 0 plus x cube by 3 factorial y3 of 0 plus x is to 4 by 4 factorial y4 of 0. Stop. Since they are asking you to expand only up to x is to 4 terms. Okay. Now here we need to solve y0, y10, y2, y3 and y4. That's it, and put here. You get the answer. Fine. So let's see how it's solved here. So first, let's write a question. So we have y is equal to e raised to sin x. Fine. It means we need to find first y of 0. Okay. So this y is a function of x. This basically means y of x is equal to e raised to sin x. So I'm writing it y is equal to e raised to sin x. So y of 0 will be e raised to sin 0. So what is sin 0? 0. So e raised to 0 is 1. That's the first answer. Understood? Now let's differentiate for one time. So y1 is equal to. So what's the differentiation of e raised to sin x? This is change of question. So see, one more time, let me make it simple for you. If you are not well versed in differentiation, e raised to sin x, very simple differentiation. Standard form is e raised to x. Differentiation of, listen carefully, differentiation of e raised to x is always e raised to x. Apart from x, if it is something other, like here sin x is a chain rule. So first you need to differentiate e only. That means, see, first function is e. Differentiation of e raised to x is e raised to x. So differentiation of e raised to sin x will be e raised to sin x as it is. Again, it is what? There is, in place of x, there is sin x. So again, you need to differentiate with respect to what? Sin x. So that is what difference sin x into cos x. That's it. Fine. Now, this can be written. See, in questions like Maclaurin series and other expansions, the easy concept of solving the question problem will be hidden in the question itself. So now you found y is equal to e raised to sin x is given. So I got y1 is e raised to sin x into cos x. So see, what is e raised to sin x? This is y. So this makes the solution more and more easier, very easier, because differentiation again e raised to sin x will be chain, it will be very difficult to solve. But taking e raised to sin x equal to y here will be very easy, because differentiation y is y1, y1 is y2, y2 is y3, so on. Okay. So always search in the solution where you can make the substitute and make the solution further easier. Okay. Now this can be further written as y into cos x. That's it, because this e raised to sin x is nothing but it is y. For that, e raised to sin x is y. Okay, it is y. Now therefore y1 of 0 will be y. See, y and y of 0 both are same. Okay. So it is y is 1 into what is cos 0? Cos 0 is also 1. So the answer is 1. So we have y1 of 0 as 1. I hope you got it. Now the next differentiation is y2. So y2 will be, now see, we are differentiating y into cos x. See, y into cos x will be product tool. See, what is product tool? Again, in a very, very simple form, when you are differentiating multiplication of two functions, use product tool. Differentiation of first into second function is keep the first function as it is, differentiate second function, plus keep the second function as it is into differentiate first function. As easy as that. So what I'll do here, y I'll keep as it is. Differentiation of cos x is minus sin x, fine, plus second function cos x as it is. Differentiation of y is y1. See, so easy, y1, y2, so on. Okay. Now it implies y2 of 0 will be, what is y? See, y and y of 0 same 1 into. See, sin 0 is 0. In place of x, you are putting 0. So sin 0 is 0, cos 0 is 1. So plus cos 0 is 1 into y1 is 1. So again this will be 1. Fine. Next, let's differentiate this y2. So again this will be y3 is equal to, differentiation y2 is y2, y3 is equal to. Again this will be what? A product tool. So how do you solve this? See, y as it is, wherever there is a minus sign, always with a bracket, it will be very easy to solve and you will not always get correct answer, you will not get confused. So we have this as y as it is into differentiation of sin x is minus cos x, because there is minus sign here, minus as it is, differentiation sin x is cos x, so minus cos x. Okay, product tool, plus minus sin x second function as it is, differentiation of y is y1, plus cos x as it is, differentiation of y1 is y2, plus y1 as it is, differentiation of cos x is minus sin x. As I told, wherever you encounter a minus sign in calculation, always put a bracket, things will be easier for you, keep in mind. Okay. Now y3 of 0 will be y of 0 1 same 1 into cos of 0 is 1, so minus 1, minus sign is there, sin 0 would be 0, and you see anything multiplied 0 0, sin 0 0, 0 to something 0, plus again cos 0 1, what is y2? y2 0 is again 1, again sin 0 0 into what is 0. So that means we have y3 of 0 is equal to minus 1 plus 1, that is 0. Am I right? 1 into minus 1 plus 1 is 0. Now last we need to find y4. So y4 will be equal to, again let's rewrite this y3 because something can be combined together here. See, this will be minus y into cos x. Let's make it simpler. Minus sin x y1 and minus sin x y1 will become minus 2 sin x y1 plus cos x into y2. Okay, now let's easily differentiate this. So again 1 2 3, there will be 3 products tool here, fine. So y4 is equal to, now we can write y4 is equal to, see, minus, take outside, put a bracket, fine. Product tool of y into cos x will be y as it is, differential cos x is minus sin x plus cos x as it is, differentiation of y is y1 minus 2 outside, again there is minus sign, put a bracket, again there is a product tool here. So sin x as it is first function, differentiation y1 is nothing but y2 plus y1 as it is into differentiation sin x is cos x. Okay, and lastly plus cos x as it is into differentiation y2 is y3 plus y2 as it is into differentiation cos x is minus sin x. Done. So my last differential y4 is done. So let's put a value here as x is equal to 0, next, that is the expansions of Maclaurin series. Okay, so we have y4 of 0 is equal to minus, I will not expand it further, I will not simplify it because anyway you are putting x is 0, I will do it here only. Okay. So sine 0, anything to 0 0, sine 0 0, so minus 0, cos 0 is 1 and y1 is what, 1, so plus 1, minus 2 into sine 0 0, anything to 0 0, plus cos 0 is 1 and y1 is 1, plus 1, plus cos 0 is 1 and y3 is 0, so plus 1 into 0. Am I right? Cos 0 is 1 but y3 is 0, that is y3 is 0. So it becomes minus 1 minus 2, that is equal to minus 3. That means we have y4 of 0 is equal to minus 1 minus 2 minus 3. So you have found all the values up to 4 differentiation. Now let us put all this value in the series what is written. Therefore e raised to sin x in series expansion is y of 0 is 1 plus x into y1 of 0 is 1 plus x square by 2 factorial into what is y2 of 0, it's 1 again, plus x cube by 3 factorial into 0 because y3 of 0 is 0, and lastly plus x raised to 4 by 4 factorial into y4 of 0 is minus 3. Sorry. So I simplified further as 1 plus x square by 2 factorial is 2 and this is 0, okay, minus 3x cube by what is 4 factorial? 4 factorial is 24. So 24, so 3 ones are and this will be 24, 3 ones are and 3 eights are. That means the expansion e raised to sin x, the Maclaurin expansion of e raised to sin x about the point x is 0 is 1 plus x square by 2 minus x cube by 8. That's the final answer. That's it. See, there is a lot of product rules and chain rules and multiple differentiation here. So everything comes upon practicing. So such questions you need to practice more and more to get the correct answer. Okay. So friends, that's all for today's class. In the previous video and today's video, we have solved some exam based question on Maclaurin series. So please practice this question. Keep watching the video multiple times. It's absolutely free. Practice it correctly so that you don't lose marks in the examination. So if the need arises further, I will be posting videos on Taylor series. So for that, please stay subscribed and stay tuned by ringing the bell icon over there. And please consider sharing with your friends and classmates as much as possible. That would be the greatest support you can give me. Okay. In the next video, we will start with the El Hospital's rule or the L'Hopital rule, the kind that always shows up in your exams. Until then, stay focused, stay strong, keep learning. Jai Hind. Bye.